For this video, we are going to give you an operation training toward the U8. First, we install the accessory storage box. Just put it in the rear panel of device. Then connect the power supply. We have a power adapter that can be left inside the accessory storage box as well. The accessory box reserves an opening hole for the power cord to facilitate the connection and storage. When connecting, insert the power cord of the machine end into the instrument port, and then connect the cord of the power end to the AC power source. Next segment is our accessories. First is the probe. This is a convex array probe, which is often used to observe the organs of the abdomen. And this is a linear array probe usually used to observe superficial vessels, nerves, and organs. When we are doing catheterization, we usually use this linear array probe. The connection of the probe is very simple, just plug it in. Next is ECG accessories. This is our dedicated 4-lead ECG cable. When connecting, directly plug the cable into the reserve port. Above all is the connection introduction of the accessories of our device. Then we directly click the power on button on the left side of the instruments to turn it on. The first we can see is the ultrasound interface. This interface is the most used B-mode ultrasound interface when we do catheterization. And please note it, when we plug in the probe at first time, we need to refresh the probe after starting up. How to do this? Click the setting button on the toolbar to enter the setting interface and touch the change probe button to refresh the probe. To conclusion, if the probe is found to be loose, or you replug it, or replace the probe, then you need to refresh the probe before it can display ultrasound images. When the probe is not in use, this wire needs to be clipped to the buckle on the back of the machine. The buckle can effectively prevent the probe from loosening, make its stress points more uniform, and prevent the probe from sagging and loosening. Then, I will introduce the operation of the machine. Before we start to use this machine, we need to enter patient data. Touch the file button on the toolbar to enter the patient information interface. And then we can enter the patient information such as name, age, department, ward number, and others. After entering the information, we can save it as a patient file. Then we start to operate. The first one is the B-mode ultrasound, which is our most used ultrasound mode. There is a gray adjustment button on the right side of the interface, which can adjust the depth of the B ultrasound, which we also call the catheterization depth. When catheterizing different body areas, different depths need to be adjusted. For example, to catheterize superficial vessels on the arm, you only need to adjust it over 20. But if you need to do a deeper vascular catheterization in the neck, such as the cervical vein, you need to adjust it a bit deeper, about 30. Simply speaking, the depth is adjusted based on the depth of the blood vessel. Then on the right side is the gain adjustment button, which is used to adjust the brightness of the image display. Take the ultrasound image of the blood vessels on my arm as an example. If I want to see deeper, I need to increase the depth. If you want the image display to be clearer and brighter, you need to adjust the brightness. The greater the value of the same brightness is adjusted, the brighter the main image will be displayed, and the lower the value, the darker the brightness will be. Usually, medical staff will adjust the gain and depth according to their own operating habits, so these are the two most used adjustment buttons when medical staff operate. In addition to clicking on the screen to adjust, the probe can also be operated on. The adjustment buttons on the probe include up and down adjustment buttons and switching buttons. The up and down adjustment buttons are used to adjust the value, and the switch buttons are used to switch and adjust the depth and gain. In addition, there is a freeze button. The image will freeze after pressing it. What is displayed now is the frozen image interface. When you want to exit the frozen interface, you only need to press the freeze button again. Finally, you can switch to ECG mode by long pressing the switch button. Then we continue to focus on ultrasound. After finishing the introduction of the buttons, let's talk about some high-end features. Click the direction buttons on the lower side of the screen to enter a parameter adjustment interface. On the right side of the instrument, there are the adjustment buttons for ultrasonic parameters, and these parameters will be displayed on the right side. Then the following are some of its functions. First, let's talk about the puncture guide. When you click the puncture guide, it will show the angles of the catheter. It can be changed according to the angles of 30, 45, and 60 if pressed again. There are a total of 3 angles that can be adjusted. Then this kind of function is generally used in this probe. We can see that there is the holder of the needle bar on the head of the probe. The needle can be fixed on the bar. The nurse can proceed with the puncture with an ultrasound probe and apply the puncture guide to adjust the angle. That is what we call the puncture guide. Then this is the center line display. The screen shows that we now have a center line. If we click the button on the screen again, then we can turn off the center line. The third is catheter. It shows the size of the catheter, because when the nurse is proceeding the catheterization, the needle size can be different from patient type including adult, child, and neonate. That is why we add this function. You can find on the right-hand side, there are various needle sizes. Nurses can compare if the size is suitable for vein. The next one is image process. Just like a Photoshop, we usually used it to blur and sharpen the image. Then, it is the M. M is an ultrasound mode applied for observing the heart valve. Generally, for catheterization, it is not necessary to look at the movement of the heart valve. It depicts the movement of the heart valve as a one-dimensional waveform, so Th is called a reversible equave. It is also the same as image processing. This also makes its image more delicate and makes the quality of the images better, and then it is also a technique for processing the image. Why should we have such an image processing and Th for clinical usage? In general, some nurses like to look at the original image when he is operating in clinical practice, which is also related to his operating habits. Generally, these 2 functions are based on his clinical operation habit. It processes the image for nurses, and it looks better, or let it display the original image. Then we click on this full screen to enter this full screen interface. If you want to exit the full screen interface, double click, or we can directly click twice to enter the full screen. And next one is the reset. It can change all settings back to default. Then look at the parameters on the left-hand side of the screen. These are settings of ultrasound image. The first one is the total gain. The total gain is the adjustment of the brightness we mentioned earlier. If we just start the interface to adjust the brightness, we can change the brightness right here, and then this the depth. The depth of the puncture. It is based on the vein location nurse need to puncture. The next one is the frequency setting. The frequency is used to adjust the frequency of the probe. We can adjust it to 13 at the highest. Generally, if we are having a superficial catheterization, we used 1/3. If you want to go a bit deeper, 10 to 12 is also okay. Then, for the contrast, it is the image processing, which helps to ensure the clearance of image. The next one is fake color. It can change the black and white color to other colors, and we have in total 11 combinations. If you want to change it back to black and white, you can simply press the minus button to 0. The following one is zoom in. It can enlarge the center of image. In this way, the clinicians can observe the details of image. Normally, we can enlarge up to 10 times. This is the settings of B-mode ultrasound if nurses want to save the report during the operation. We can click the middle button to freeze the ultrasound image, and then we can recap here. We can play back to ultrasound image up to 2 minutes. Under image freezing, we can click the save button. It is saved in the device. Next to the saving button, it is vessel and catheter size estimation. We can try to drag the blue circle on the right-hand side and place it on the vessel. You can try to change the outer circle and estimate the size of vessel, which proves out if that catheter size is suitable for this vessel. Again, the blue circle outside is matched to the vessel, and the inside circle is the size of catheter. Normally, 4F to 6F is suitable for adult vessel estimation, and then 2F or 3F is used for neonate. The distance button is used to measure the length and is generally used to measure the diameter of the blood vessel when evaluating superficial blood vessels. Click on the screen. A straight line will appear, and the blood vessel diameter value will be displayed on the screen. The square button is used to measure the cross-sectional area of the blood vessel. Click on the screen. An area circle will appear, which can be zoomed in and out, and the area value will be displayed on the screen. The circumference button is used to measure the perimeter of the blood vessel cross-section. Click on the screen. The perimeter circle will appear, and the perimeter value will be displayed on the screen. After the measurement is completed, you can click the Save button to save the measurement data as a picture format and print it out. The Delete button is used to delete these measurement images. The Print button is used to print these measurement images. There is a USB interface on the back of the instrument, which supports the external connection of any type of USB laser printer. In addition, there is a network port on the back of the instrument, which supports connecting to a computer and transferring these measurement images to the computer. In addition to B mode, the ultrasound imaging modes also have C mode and D mode. C mode is color Doppler mode, which adds blood flow color display based on B mode. The green frame is the sampling frame, and the blood vessels in the sampling frame will be displayed in red or blue. There are adjustment bars on both sides of the interface. One side is for adjusting the depth and the other side is for adjusting the brightness. Click the direction buttons on both sides. The function settings will appear. Click the center line button. The center line will appear. There are also full screen and reset functions. Click the frame button to enlarge or reduce the sampling frame. In addition, the position of the sampling frame can be adjusted. You can place the sampling frame at the desired position. There are some adjustment functions here. Color gain is to adjust the color brightness of the blood flow color. Impulse is the same as the frequency adjustment of probe in the B mode, and the parameter is generally set to the default setting. Offset angle is to directly adjust the angle of the sampling frame to make the blood vessel appear more clearly. Wall filter is to adjust the image. You can add and subtract to process the image. Color flip is to swap the red color showed when the blood flow direction toward the probe and the blue color showed when the blood flow direction away from the probe, and the colors are reversed. Next is contrast, which is a parameter for image processing. When we measure a blood vessel, we can measure its transverse section or its longitudinal section. When we measure, place the probe at 90 degrees to the blood vessel, and we can see a cross-section of the blood vessel. If we want to see the longitudinal section, place the probe parallel to the blood vessel so that the longitudinal section of the blood vessel can be displayed. The current display is C mode ultrasound. In addition to C mode, we can also support D mode ultrasound. D mode refers to Doppler ultrasound. Next, we click on the D mode ultrasound button to set the Doppler parameters. Doppler is mainly used to measure blood flow velocity. When we enter the Doppler parameter setting, we first need to click sync, and then we can display the blood flow velocity waveform of the blood vessel that is currently being measured. If you need to freeze a waveform for detailed observation, you can click the switch button on the screen to freeze the waveform. Besides these, we also can provide full screen and reset function. Last, there is the sampling button. After clicking this button, we can adjust the position and size of the sampling frame. Next, we look at the left side of the screen. Shown here is the parameter setting button of D mode ultrasound. Firstly, D gain and impulse. These two functions are the same as B type. Secondly, wall filter, denoise and contrast are all functions for processing images. Third, sampling vol refers to the sampling volume, which is used to adjust the size of the sampling frame. Fourth, revise angle. We need to ensure that the angle between the blood vessel and the probe is less than 60 degrees when measuring. If the angle is too large, we need to adjust. In the actual operation process, it is to adjust the inclination angle of the diagonal line in the sampling frame. Fifth, baseline. The baseline is the white line in the middle of the waveform display frame, just like our ECG. If we only need to see the positive blood flow waveform, we can adjust the baseline position downward. If we only need to look at the negative waveform, then adjust the baseline position upward. Sixth, spectral is used to exchange the blood flow waveform in the positive and negative directions. The positive waveform becomes a negative waveform, and the negative waveform becomes a positive waveform. Next, we will talk about waveform freezing. B, C, and D images can be frozen, but the difference is that in D mode, more hemodynamic related parameters can be displayed. For example, firstly drag index. When we click this button, and then click different blood flow waveform positions on the screen, the resistance value of the blood vessel at the current position can be displayed. Secondly, blood value. After clicking this button, click the blood flow waveform graph to display the blood flow peak value at the current position. Third, time measuring refers to measuring the blood flow time for a certain distance. Fourth, blood refers to blood flow. Fifth, pulse index. Sixth, HR. Therefore, some of the parameters pointed out here are often mentioned in hemodynamics. And after the measurement, we can save this data or print it. Patient files. The patient file contains patient information, history review, ultrasound images and ECG waveform review. The patient information includes the patient's number, name, age, gender, diagnosis result, and doctor's order. Finally, we must click Save button to save the case. Historical review can review all past patient records. We can use a USB flash drive with a USB interface on the back to connect to the USB flash drive, and then export all personal information, and then view it on the computer. Ultrasound images are the frozen images we mentioned earlier, and they are all stored in the ultrasound picture review. We can export these materials, and then print it out. The ECG waveform can be viewed in ECG waveform review. We can also print directly here. This is the end of patient information and patient data review. The next button is its system settings. The first is the setting of the image, and the one on the right is the catheter for selecting it. The default catheter selection means that if we say which catheter we have frozen before, then it will identify which catheter it is. Here is the probe change. After we unplug the probe and reinsert it, the probe must be refreshed, otherwise its image will not be displayed. Then sometimes if you have a black spot and a white spot in the image, you also need to check whether the probe is plugged in properly and tightly, and then plug it in again. And then click the button to refresh the probe. Then there is automatic freezing here. It indicates that if there is no movement for 10 minutes there, we will automatically freeze it. And the second is the ECG setting. Here the ECG waveform speed can be set up, and then the opening of its grid and its gain could also be set up here. It is the same as the settings of our electrocardiographs and patient monitors. Then here the gain is to set its ordinate wave height, which is the voltage. And here it is the name of a printed report, and you can set it here. Then the next one is the common settings. In the common settings we can set the demo mode, and then set the date and time. If there is an external laser printer, we can select the information that needs to be printed out here, and tick the attending doctor, bed number, age, gender, etc. Then all the selected information will be printed out. The next one is network settings, which is for connecting the computer. User can enter the IP address. After we connect to the computer, all our images and waveform will be uploaded to the computer and can be opened in a folder of computer. The last one is the menu set setting. For the factory setting, we can set the language and upgrade the manufacturer's program. Then let's see the last function. The last function is our ECG. In addition to switching to ECG mode on the touch screen, we can also switch to ECG mode by long pressing the switch button on the probe. Then select the button up and down to select the 3 waveforms that are going to be frozen. For example, we select the body surface, and then click the freeze button. Then the body surface is frozen, and then select the bidirectional waveform in the body. Then the bidirectional waveform in the body is frozen. The lower button is to freeze the case. These are accessories of our ECG, and we made 4-channel ECG specifically for PIC line location. This is also our patent, which is not available from any other manufacturers. Then, among the full LEDs, the blue one is the alligator clip, which is clipped on the infusion needle. Then the other 3, the white, green, and red ones, are attached to the body surface. The white one is attached to the shoulder on the left side, the red one is attached to the lower abdomen on the left side, and the green one is attached to the lower abdomen on the right side. These are superficial measurement. Then this blue one is interior measurement, with this alligator clip. Generally, we connect the body surface clips first, and then clip the alligator clip, which is clipped to the needle of the infusion. Now let's look at the operation of the device. Here is a real-time ECG waveform of the internal body and the body surface. Here, the three waveforms are frozen waveforms. We firstly connect the body surface clips. After the waveform, we can see that the waveform of the body surface will appear, and then we will find a clearer waveform and click to freeze. If this section of the waveform is not what we want, and we can freeze it again, the waveform will be frozen if you click it, and it will overwrite the previously frozen waveform. About the internal waveform, after the bidirectional wave in the body appears, we click the internal bidirectional wave to freeze it, and then pull the catheter slightly out for 1 to 2 centimeters. Currently, the highest peak of this P wave appears. Then we click on the best position in the body, then these three waveforms are frozen. After freezing, it means that the tip of the patient's catheter is at the best position. At this time, we can press the middle button to print it out. Then on the right side is the intelligent analysis software. We click on it to perform intelligent analysis and analyze where the tip of the catheter is. Its principle is to cut a waveform through the DLEDs inside body and the body surface, and compare and display the comparison. Then it will intelligently analyze whether the catheter enters the superior vena cava and whether it enters the new atrium. This is the whole operation training of our U8. Thank you for watching. Have a great day.